When an earthquake strikes, the ground starts shaking in many different ways. The houses that are not sturdy enough may collapse, causing great losses. I am Architect Kiki. Do you know how to build houses at different locations? This is a seismic hazard map. The colors and numbers marked on the map indicates different levels of earthquake resistance required in house building. Wherever it is, houses should be sturdy. Can you place the buildings at the matching zones of seismic fortification intensity? Level 9 Fortification Zone. Level 8 Fortification Zone. Level 7 Fortification Zone. Level 6 Fortification Zone. Now let's build the sturdy houses to stay safe even when earthquake strikes. Villa. Let's build the brick wall first. Scrape off the excess cement. Bind the rebar columns with rebar rings. Fix it in place with steel wire. Let's fix the mold. Fill the steel reinforcement cage with concrete to make a sturdy constructional column. The steel reinforcement cage of the beam and the steel reinforcement cage of the column must be connected when building each floor. Next, pour in the concrete to make a sturdy ring beam constructional column. Thus, the houses are sturdier and more earthquake resistant. Pick a roof you like. Then pick the color to paint the wall. The villa is built. Great job! Buildings with ring beam structural columns and buildings without ring beam structural columns will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Wooden pavilion. Let's start sculpting the wooden parts. Use sandpaper to polish the rough wood. Apply waterproof paint so that the wood would be sturdy and durable. Let's assemble the bucket arch. This is a bucket arch. It is pieced together by 3 wooden parts. The wooden parts are not fixed to one another. Placing the bucket arch between the roof and the columns not only supports and stabilizes the structure of the entire house, but also absorbs some shock waves by deformation during an earthquake, which reduces the risk of collapsing. Pick a roof you like. Apply the cement. Let's put some tiles on the roof. Then paint the columns. Wow! The wooden pavilion is built! So pretty! Buildings with mortise and tenon joints and normal buildings will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Skyscraper. We will need some steel components for building a skyscraper. Lift some up from the ground. Sort out the steel components by their shapes. Tie the steel components into bundles. Lift the steel components up for building the roof of the skyscraper. Slide the lever to the left and right to put the steel components in the right place. Hit the steel components with the hammer to align them. Now let's build an enormously big wind damper on the top of the building. Pull the handle to hoist the iron ball. Tighten the screw to fix the iron ball in place. Now install the small damper to connect the iron ball to the foundation. Spin the wrench to fix the screw. The iron ball of the wind damper is very big and heavy. It is as heavy as 132 elephants. Fix it in place on the top of the skyscraper. During a typhoon or an earthquake, it will swing from side to side so that the skyscraper is sturdier and does not shake. Wow, the skyscraper looks so grand! Buildings with shake reduction measures and buildings without shake reduction measures will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Factory building. Do you know where it's safer to build a house? Is it on the seismic faults? Or is it on flat ground? That's right! Houses that are built on the seismic faults may collapse when an earthquake strikes. Houses should be built at a safe location. Let's start digging! Now let's fill it with layers of different kinds of materials. We'll still need some concrete to fill the foundation pit. This is a concrete mixer. Let's make some concrete. Add the raw materials first. Stones. Cement. Sand. Pour them all into the mixer. Screw the hose pipe to add some water into the mixer. Let's start mixing the concrete. And the foundation will be sturdy. Good job! Select a factory building. Wow, the factory is built! Great job! Buildings with modified foundation. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Can you place the buildings at the matching zones of seismic fortification intensity? Level 9 Fortification Zone. Level 8 Fortification Zone. Level 7 Fortification Zone. Level 6 Fortification Zone. Now let's build the sturdy houses to stay safe even when earthquake strikes. School building. The government has increased the seismic fortification criteria. Now we need to strengthen the school building's earthquake-resistant capability. Let's set up the temporary fencing for the construction site first. Safety is the priority in the construction site. Place the safety signs here. Turn the knob to move the aerial work platform up. The steel frame is a bit rusty. Polish it with sandpaper. Spray paint the steel frame so that it won't rust so easily. When an earthquake strikes, the damper on the energy dissipation device can deform to dissipate or absorb the seismic energy, thus efficiently prevent the collapsing of the building. The school building is reinforced. Great! Buildings with seismic strengthening and buildings without seismic strengthening will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Mall. Here are some bent rebar. Use this machine to straighten the rebar first. Let's make a core tube shear wall first. The core tube shear wall is in the center of the building. It is built of reinforced concrete instead of bricks. The shear wall structure can resist lateral forces and has strong earthquake-resistant capability. Pour the concrete onto the floor slab. even. The floor is done. It looks nice. The mall still lacks shiny signboards. Wow, it's such a gorgeous mall! Good job! Buildings with seismic strengthening and buildings without small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Bridge. We're going to build a bridge here. However, the underwater foundation is very soft. We must reinforce it first. The foundation soil is soft underwater. Pierce the pile foundation through the soft soil into the bedrock to make it sturdy. Thus, the pier will stand in the water sturdily. Now we need to install seismic isolating bearings in between the piers and the deck. Now let's build the deck. Connect the deck and the columns with wire cable so that the bridge will be sturdier. The bridge is built! What a pretty bridge! Is the bridge we built sturdy enough during earthquake? Let's check it out by swiping the button. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going! Hospital building! The old building is in danger of collapsing. Let's dismantle it first. Set up the bearing base plate. Pour cement onto the steel reinforcement cage to make sturdy pile foundation. Time to install the seismic isolation bearings. Make sure all the screws are tightened. The foundation is built! These soft and flexible rubber seismic isolation bearings work to isolate the house from the ground. When an earthquake strikes, the isolation bearings deform to isolate the house from the shaking of the ground and keep the house much safer. Select a hospital building. Wow, the hospital is built! Oh, we also need to build a helipad. With the helipad, helicopters will be able to send patients to the hospital faster. Earthquake earthquake-resistant buildings and normal buildings will act differently in an earthquake. Slide the button to check it out. Small earthquake. Stay intact in a small earthquake. Medium earthquake. Repairable damages in medium earthquake. Big earthquake. Won't collapse in a big earthquake. Great job! Wow! The earthquake-resistant building you built is so sturdy! Amazing! Keep going!